So we have example 2b4. The given is end B of the link moves to the right with the speed of VB. And we are supposed to find for the position where theta is equal to 30 degrees using the method of instant centers find the angular velocity of AB. And then we use the following parameters in your analysis. VB equals 3 meters per second, L equals 0.5 meters, and theta equals 36.87 degrees. So I wrote all the givens out in the finds, and we're finding omega AB. We're given theta equals 36.87, velocity of B is 3 meters per second, and the length is 0.5 meters. And here's our diagram. So we were given the direction of VB, and it's going to the right. So then we know that omega AB is going counterclockwise, because VB has to go in the same direction as omega AB. And so then we can conclude that VA is going either up or down, and since the omega is going counterclockwise, we know that VA is going down. And then we draw the red lines that are perpendicular to each of our velocities, and we find the point of intersection, which is given at IC of AB. And we decided to call this line, this length D, and this length Y.
First off, we're going to start by creating a velocity equation from A to B. VB equals VA plus angular velocity AB cross product to our distance R. First, you're going to do that, and you're just going to set everything in terms of I and J. So VB, since it's going horizontal, it's going to be in the I direction. VA, J, angular velocity K, and our two Y and D, which we're going to call, which we labeled right here, the distance to the instant center and the I and J components. After you do the cross product between those two, this is what you're going to get. VBI equals negative VAJ plus angular velocity YJ plus angular velocity AB times D in the I direction. After you get that, you're going to set it into all the I components together, so you're going to end up with VB equals angular velocity times distance D. When you're solving for angular velocity, set everything in angular velocity. So you're going to do VB divided by our distance D. D over here is going to be, after doing some simple geometry, L sine theta. Plug it in, put the numbers in, 3 for your velocity, 0.5 for the length, sine our degrees 36.87, and that's going to get you 10 radians per second.